So we are live now. You can start.
Welcome to the World Environmental Day 2000, World Ozone Day of 2020. On behalf of myself, Dr. Gufran Beig, from Indian Institute of Tropical Meteorology, Environmental Information Systems Center at IITM Pune, and on behalf of Dr. Rajendra Shende, who is a director of TERRE Policy Center, jointly organized this World Ozone Day 2020. I welcome all of you. Indeed, it is a matter of great pleasure that we have two very eminent speakers of the who is who in ozone layer who have joined us, whom you will be listening. But before I get into further, I just wish to introduce you to my team, and I just want to convey my gratefulness to them because they are the one force behind it, who have been making all this to happen, invitations and background and everything what you will see. One is Dr. Samir Dapre, who is a program officer in ENVIS. Then Mr. Gaurav Shende, who is also from ENVIS Center at IITM Pune. And then Ms. Darshana Jadhav, who is also in ENVIS Center at IITM Pune. From TERRE Policy Centers to very dynamic young people, Mr. Saurabh Datta and Mr. Rohan Atrawalkar. I sincerely thank both of them. Before I get into my some 5 minutes introduction, I just want to start with a friends that we know that there is a tsunami of webinar around the globe. And in this scenario, we need to have a sequential decision making with a dexterous approach to learn from these events. This is just like coming home, discussing, filtering the useful information which would make our environment better and make the world a great place for us and our coming generation. So friends, stay tuned for next 90 minutes or so and enjoy this unique event. With this, I would like to now share and start my 5 minutes introductory to set a stage.
Samir, I want to make sure that is the technical parts is perfect.
Sir, actually, we all have to stop screen sharing, and then the speaker only should share his screen and video.
So Shende sir, can we stop screen sharing so that I can share a screen?
Yes. Paul sir, please stop sharing your screen because it is being seen on YouTube and the screen.
Samir, what do you mean by stop sharing? I'm not sharing at all.
No, sir. Dr. Paul sir is sharing his screen.
Okay.
So yes, he can. Yes. Now it's clear.
Yeah. Now from where? Share your. Okay, fine. Share. Okay, my first slide is visible to all of you.
Yes, now it's visible.
Yes. So this is just to, as I said, that just to set a stage, just I will give a preamble for a few slides. And as you know that there are two kind of a ozone. One is a bad ozone, another one is a good ozone. We are talking about a good ozone, which remains in the stratosphere above 15 kilometer up to about 50 kilometer with a maximum thickness at about 25 kilometer or so. The one which is close to our surface is a pollutant, greenhouse gas is not good for us at all. So this is just with this introduction, I just wanted to, for a people, youngsters, that the discovery of ozone, you must be wondering that it has happened sometime in 1785. And after 55 years, until about 1840, Christiana Schonben has detected the same peculiar odor in the oxygen, and he has named it as ozone after the Greek word which says is a bad smell. Then the ozone chemical formula was not discovered until 1945. In fact, when 1945, this ozone, La Riva and Jen has suggested that it should be an ozone, oxygen is there in that one. And then in 1861, Olding has suggested that formula for ozone should be O3. And this is what you see, that ozone formula. Now, just one slide for ozone research in India. The father of ozone research in India was Professor K.R. Ramanathan. In 1925, he joined India Metallurgical Department, remained there until his retirement in 1948. Then same year, he joined Physical Research Laboratory in Ahmedabad as the first director. And he is one of those who is a pioneer in development as well as establishing the Dobson, which is the first polymer ozone measurement instrument in India. And he retired in 1966, but thereafter he continued to remain in Physical Laboratory until his demise in 1984 at the age of 91. And just for the curiosity of those people, you will see that in the right hand side, you will see the father of space science, Professor Sarabhai, then Professor K.R. Ramanathan, then Mrs. Sarabhai was one of the well-known dancer of her time and then academies she has established. And then the person who is in the extreme right-hand side is Chapman, Professor S. Chapman, and you must be hearing the person, the Chapman theory for ozone production. He is the one who has discovered that particular thing. Now, so this was all about ozone, but then the problem started when the ozone hole was discovered, and this gentleman who passed away in 2014, Mr. Joseph Farman, in a Antarctic station, he was there and he saw a phenomenal decline, dramatic decline in ozone column in the Antarctica, and that was a shocker to the scientists globally, and that is where all this thing started. And since the research has got so much hot up, this is the first time that atmospheric chemist is getting a Nobel Prize in the chemistry in 1995, which is jointly got by Paul Crutzen, Mario Molona, and Sherry Rowland. And they are all whose photographs are here, which is for their seminal discoveries on chemistry of ozone. Then the efforts started, international efforts. And in 1987, Montreal Protocol on Substances and Depletion of Ozone has done, which led to a success story. What are those success stories, how it has been reached and all? I am not going to talk anything about that. This is what is left us to our. So the only thing is that I will just put more 2 slides, that it is not that all through we have to be very happy that ozone is getting recovered, which our speakers are going to even throw the light. But there are challenges which are always there for tomorrow. And specifically tropical region, where our country, India, falls in that. Reason is very simple, that tropical ozone level are most sensitive to greenhouse gases, led by CO2 and 2 and methane, which are increasing under climate change, and to deplete ozone very effectively, which get aggravated in tropics due to greater Dobson circulation. And there are model predictions that significant decrease in column ozone by the 21st century in the tropics, which includes India. So we have a 3 challenge if we want to break this particular catastrophe. Abating climate change is vital for tropical ozone in future. Aerosol increase may pose a challenge for Indian ozone layer. And the third one, air pollution may put a challenge. We need to tackle all those things. And the last slide is, many of you must be hearing that we are in a very tragic time where the coronavirus is happening. And as I told you, that near the surface, ozone is a very bad, it is a pollutant, it is a pungent smell, it is a poisonous gas. But there is a thing that ozone, whether it is bad or is it protecting shield for COVID-19. This is known that ozone as a disinfectant is one of the wonderful disinfectants which can kill the coronavirus. Ozone breaks through the outer shell of DNA, RNA of the corona COVID virus. Then, but the point is, during this time when the sky is clear, there are no aerosols, there is no reflection or reflection back of the UV radiations. UV radiations are reported to be increasing, and that was one of the reasons that ozone is also reported to be increasing after the lockdown. This is we also observed there is an increase for something like about 20 to 30 to 40% increase. Sometime we found it in one of the major urban areas because NOx has declined, so the titration reaction took those kind of things. But we should not be in illusion that this is killing virus and the COVID-19 will go, because ozone continue to remain as a harmful, because for killing the virus you need concentration in terms of a ppm, and ambient we are talking in terms of a ppb. So now you must be having lot of question, quest for more, and that is where we would like to have a to discuss this, to listen, and eagerly waiting to listen to our eminent two keynote speakers who is who in ozone. But before I invite them, I request Samir to just play a video which has been received from United Nations Environmental Program, which is just 20-30 minutes, and thereafter we will provide a very brief introduction to our first keynote speaker, Professor Paul Newman, and then I will request him to do this. So Samir, can you please play the UNEP small video? This was the video received. Now, before I invite within a minute time to our first eminent keynote speaker, I request Samir to kindly introduce him through a video slide. Samir.
Yes, sir, just a minute.
Keynote speaker, Dr. Paul Newman. Dr. Newman is one of the world's top leading scientists from NASA, United States. If we call him ozone layer protector and warrior, then it would not be an exaggeration. Dr. Paul received many prestigious awards and recognitions. To mention a few like Scientific Awards, Montreal Protocol Award in 2017, Champions of the World Award from United Nations Environment NASA Group Award. He is a Fellow of American Meteorological Society, recipient of prestigious Arthur Fleming Award, and the list is long. Dr. Newman published more than 200 top scientific papers, enriched the world with many public talks. We welcome Dr. Paul Newman from NASA to deliver his World Ozone Day talk and have a dialogue with us.
Please welcome, Professor. Please share your screen. Yes.
Can you hear me?
Yeah, just play.
Great. And can you see my screen?
Yes. Go ahead.
Great. So my name is Paul Newman. I'm from NASA, the National Aeronautics and Space Administration. I work just outside of Washington, D.C. And today I want to talk a little bit about the world that we avoided, but because we have a Montreal Protocol. And it really is a global success story. And I want to show you that that's true. So I'm going to start off by talking about chlorine chemistry. Now, the two people you see here on the left side of the screen is Rich Stolarski, and on the right side of their screen is Ralph Cicerone. Now, these two scientists discovered back in 1973 that chlorine atoms could catalytically destroy ozone. That is, one chlorine atom can destroy an ozone molecule and then regenerate itself and destroy another and destroy another and destroy another. So it just goes through eating ozone molecules. In fact, one chlorine atom can destroy thousands of ozone molecules. So it's a very efficient compound destroying ozone. So they discovered this back in 1973, 74. And that was followed by the two gentlemen that Dr. Beig already mentioned. Gufran mentioned them. Mario Molina on the left side of the picture and Sherry Rowland on the right. What they found is that human-produced compounds, chlorofluorocarbons, were increasing in the atmosphere and that they could lead to the depletion of the ozone layer. This was a 1974 important finding back in 1974. Now, what are these ozone? 12 chlorified. There's a 11 contain bromine. Then growing ozone, then chlorine. About solvent compounds used for? Well, first of all, they're used as solvent. Conditioners, aerators, and air conditioners, and for
Hello, Paul sir. Hello.
Hello.
Hello. Sir, we cannot hear you, Paul sir. Sir, check your mic, sir.
it's the bromine compounds, halon 1211, halon 1301. So what would have happened if Sherry Rowland and Mario Molina had not discovered the CFC ozone problem? Imagine that the CFCs just kept increasing 3% per year starting in 1974. And by 2065, if you did that, CFC levels would have been about 40 times the natural level. So what we did is we put this into a state-of-the-art chemistry climate model that completely simulates the weather, the climate, the chemistry of our atmosphere to see what happened. So there's Mario. Let's assume that destroy the ozone layer. This is what the models showed, that if be about, is going to down, there'd be about a 30% crude in 79, crude models back in 1979. And it fell back. The chlorofluorocarbons. We did is we took a 1996. Now what we did is we took a fluorocarbons. So here's a plot of the level of to the fluorocarbons running from 3 simulations here. We just take the observation is the observation. So we just take the observation as and then they protocol. The other 1960 chlorine level. What if we never use? So the then there's so the to have effect ratified. It took a couple of years to have effect. Increasing in our atmosphere. Take a billion molecules, only 40. So let's see what happens in that. It's 960 level, so see. Usage was increasing, 70 CFC usage was increasing by anywhere from 5 to 9% per year. So that's 33% per year is kind of conservative growth rate. So now this is total ozone across the globe. You can see we measure it in Dobson unit. Dobson unit is just a measure of the thickness of the layer of ozone above our head. So the total amount of ozone between the surface and space. And 300 Dobson units, which is right there up towards the top of the scale. 300 Dobson units is equivalent to a layer. If you could bring all the ozone down as a gas to the surface, it would be a layer 3 millimeters thick, so centimeter, 0.3 centimeters ozone in our atmosphere. The ozone, there's not a lot of ozone in our atmosphere. Simulation. It went down, but in the future, if you never had this is the world. To 2065, virtually 2 high Arctic 70 to 90 and
Hello, Paul.
so it stays fairly high. You can see 5.
Paul, your
Yeah.
voice is breaking. It's not clear at all. So I think there is a network issue locally because there are a lot of messages. So
Can you start from the beginning again?
because it was not at all clear.
Yes, not to me also. Can you hear me? Start from the beginning again.
Because it was not at all clear.
Now, is it clear now? Yes, not to me also. Can you hear me? Start from the beginning again.
Okay.
Because it was not at all clear.
Paul, can you hear me?
Is it clear now? Yes, not to me also.
Yeah,
Now,
but-
start from the beginning again.
Okay.
because it was not at all clear.
Paul, can you hear
Now,
me?
is it clear now? Yes, not to me also.
Yeah, Paul, let Paul speak. Let Paul speak.
Okay.
Because it was not at all clear.
Paul, can you hear me? Is it clear now?
Asa Goddard, here just outside.
Again, Paul, no voice.
Asa Goddard, here just outside.
Hello, Paul. Hello, Paul.
Again, Paul, no voice.
Asa Goddard, here just outside.
Hello, Paul. Hello, Paul.
Again, Paul, no voice.
Asa Goddard, here just outside.
Hello, Paul. Hello, Paul.
Again, Paul, no voice.
Asa Goddard, here just outside.
Hello, Paul.
Hello? Hello?
Have we lost Paul? Gufran, can you hear me?
Can you hear me?
Paul, I can hear you just now.
Paul,
Okay. I'm
can you
gonna
hear me?
not run. I'm gonna not run my video, but I will share my
Can
screen.
you hear me? Paul, I can hear you just now. Paul,
Okay. Okay. Yeah, I can hear you, Raj.
can you hear me?
I'm gonna not run my video, but I will share my screen.
Paul, I can hear you just now. Paul,
Okay. Okay.
Yes.
Yeah, I can hear you, Raj.
can you hear me?
I'm going to not run my video, but I will share my screen.
Paul, I can hear you just now.
Okay. Yes. Yeah, I can hear you, Raj. I'm going to not run my video, but I will share my screen. So I'm getting a lot of feedback.
Can all of us can mute our mic now and let Paul speak?
That'd be good. If everybody will mute, I think I can carry on here.
Can all 5 of us can mute? Paul,
Okay,
go
Gufran,
ahead.
everybody.
I think everybody has muted. Now, please go ahead.
Okay.
Now, Paul, I think now you are audible.
Okay, great. And I'm. Can you see my screen, Gufran?
No, you have to share that.
Okay.
You lost it, I think.
Had. Okay, let me know when you can see the
Yes,
screen.
yes, we can see that now. Just play it.
Okay. Okay. I'll try to go slow. So hopefully we can get through this.
Perfect.
So let me start off by talking about chlorine. Chlorine is an atom that can catalytically destroy ozone. So one chlorine atom can destroy an ozone molecule, regenerate itself, and then destroy a second, and a third, and a fourth. Your average chlorine atom can destroy thousands of ozone molecules if it gets into the stratosphere. Now, this was first discovered by Rich Stolarski, who is on the left side of the screen here, and Ralph Cicerone, who's on the right side of the screen. Now, this 1973-1974 paper was followed by the work of Mario Molina on the left in the picture and Sherry Rowland on the right. And they found that the source of chlorine in the stratosphere was chlorofluorocarbons. These are human-produced gases containing chlorine that can lead to ozone depletion. And in fact, they postulated that chlorofluorocarbons were an existential threat to the ozone layer. So what are these ozone depleting substances? Here's a list of them on the left. They are used as solvents, degreasers for electronics. They're used in refrigerators for the refrigeration unit and for actually the insulation in the refrigerator. They're used in air conditioning units. They're used in car air conditioners. They were used in meter dose inhalers. They were used as aerosol propellants. They were used to make plastic cups and little containers for food. And the halons, which contain bromine, were used in fire extinguishers. Now, bromine is very efficient for ozone depletion. In fact, bromine is 60 times more efficient in ozone depletion than chlorine. So bromine is a very, very effective ozone depleting substance. So the question that I want to answer today is, what would have happened if CFCs had kept increasing 3% per year starting in 1974? So this is the year that Rowland and Molina paper was published. If you do that, by 2065, the CFC levels would have been about 40 times above the natural level. So we're going to use a state-of-the-art chemistry climate model to simulate the weather, climate, chemistry of our atmosphere and find out what's the impact on ozone. So there's Sherry Rowland on the left and Mario on the right. And let's assume they never did their work and see what happens to the Earth's atmosphere. Now here's an early simulation. This shows 1975 fixed release rate. That's number one. This controlled after 2000. You can see ozone recovers. That's great. Number two is where you just have a fixed release rate that was constant going in the future. And then three was a 5% release rate per year. You can see that within not too long, you're getting very, very large ozone depletions. Now, the problem with this model that did this simulation is this was really crude model. Very crude. It's what's called a one-dimensional model. So it just represents a single point going straight up. This is another relatively crude model that was done in 1996 by Michael Prather, and this indeed also showed that ozone would decline if you did not control the ozone-depleting substances. So now we're going to show a simulation in which ozone or the ozone-depleting substances keep increasing. CFCs increase uncontrolled. Now there are going to be shown 4 simulations. The first is a green line, that's at the bottom there, in which chlorine is fixed to 1960 levels. So the CFCs are at relatively low levels, and they stay that way through up to 2065. The second simulation is forced by the observations of CFCs. So we put the right amounts of CFCs that are actually observed into the atmosphere, and we see how the ozone layer evolves. And then the red line is the projection going out to the year 2065. So ozone depleting substances, as Gufran already mentioned, because of the Montreal Protocol, they're declining in our atmosphere, which is a really good thing. That's the success story of the Montreal Protocol. And then there's, the Montreal Protocol and its amendments stop the growth of CFCs. That's what the blue line and the red line showed. But in the world avoided, the CFCs keep increasing. And you see by the end there in 2065, you get up to about 45.6 parts per billion of chlorine in our atmosphere. So that's about 40 times the natural level. Now that's in parts per billion. So if you take a billion molecules, about 46 of them by the year 2065 in this model simulation would be chlorine. So that's not a lot. So what happens so there's going to be 4 simulations shown. They'll always be the same color. The path, the future, the world where CFC levels were small, and the world where CFC levels increased 3% per year. So here's the first simulation. And you can see on the left is the total amount of ozone averaged across the globe. Dobson units, it's represented in Dobson units. And this represents the thickness of the ozone layer above our heads from the surface all the way to space on average. Now, 300 Dobson units is not a lot of ozone. If you could bring all the ozone molecules above our heads down to the surface, it would form 300 Dobson units is equivalent to a layer 3 millimeters thick. So not very thick at all. There's not a lot of ozone above your head, but this is a vital gas, actually. What happens in the world avoided? Well, chlorine keeps going up and ozone across the world plunges. By 2065, 2/3 of the ozone layer has been destroyed. That's not good. What about the Arctic? This shows a picture of the Arctic. So the line, you can see the picture there in a 1980 simulation. This is actually April of 1980 in the model, and it's 70 to 90 degree average. And so you can see that ozone is pretty high over the Arctic at the end in the springtime. That's in 70 to 90. If you go forward to 2020, you can see that ozone is going down quite dramatically. And instead of having, you can see the little picture here, instead of having a maximum of ozone above the Arctic, there's actually an ozone low there. An ozone hole is beginning to form above the Arctic. And then by 2060, there's the picture you have over the Arctic. You can see that not only do you have a very, very low values over the Arctic, but you have low values everywhere across the world. So compare the 1980 picture to the 2060 picture. Ozone has gone down remarkably everywhere because CFC's increased. So this is in the tropics. This is ozone levels at an altitude of about 20 kilometers in the tropics, 10 south to 10 north. And I've shown the various different kinds of chemicals in the tropics, how chlorine, it starts off as a CFC, but it gets broken up. And you can see that the chlorine is increasing in the tropics quite a bit, but that suddenly in the year, about the year 2055 or so, ozone suddenly plunges downward. And this is because, very interestingly, that the chemistry that we see in the Arctic stratosphere, the Antarctic stratosphere, begins to develop in the tropics. So we virtually get an ozone hole developing in the tropics in this world avoidance simulation. And it happens really fast. Now, what about UV, ultraviolet? So ozone, and the reason it's so critical is because ozone screens solar ultraviolet radiation. Now, ultraviolet radiation is energetic enough to break the bonds of biologically active molecules like DNA, carbohydrates, and so forth, RNA, everything. So this shows the UV index, okay? At latitude, and this is the world avoided, starting back in, you can see that we start back in the year 1970. You can see it increasing, and then by 2060, you're getting UV indices on the order of 40 to 45, 30s to 40s at the very end of the simulation, because ozone is so low, so more UV is penetrating to their surface. Now, this is bad for things like skin cancer and cataracts. So they were going to have a very dramatic impact in this world. Now let's talk about crop yields. This is a comparison of two simulations, and it's done by the Rickless et al. And what they did is they did a simulation where they increased UV by they increased UV by depleting ozone. So they had a 25% ozone loss. And this shows the relative fraction of the crop yields. So, you lose crops. Some is lost in the harvest, some is lost to insects, some is lost to disease, some is lost to weeds. In their simulation, if you deplete ozone, you get a huge loss of crops. 25% ozone, 20% of the crop would be lost because of ozone depletion. So what does this mean? Well, here's the food security. This is what we've done is we took a look at what would happen if we increased UV. In June of 2011, or just a few years ago, because UV would have increased, there would have been about a 10% crop reduction, for example, in India. By 2047, you can see that because ozone had gotten so low, there were enormous crop losses in India and at the higher latitudes, up to 90% in the high latitudes. So huge UV damage. Suffice it to say that plants growing at the surface by 2065, they would have been heavily damaged by the huge UV doses that they were getting per year. So let me just summarize here. Using a modern model, we can show that unrestrained CFC growth would have led to massive ozone loss and cancer and other effects like crop yields. Cancer would have gone up, crop yields would have gone down, sunburn times would have gone to very short times. Just walking outside for a short period, you would get a sunburn. So the Montreal Protocol really did work. These ozone-depleting substances, CFCs, were an existential threat to the ozone layer. But fortunately, the ozone-depleting substances, they were controlled, and the ozone layer is showing the first signs of recovery. And finally, one thing I didn't mention was that ozone and CFCs affect climate, and CFCs are powerful greenhouse gases. So if we hadn't controlled the ozone CFCs and ozone depleting substances, there would have been a lot of warming from those same gases in addition to carbon dioxide. So that's all I have. Thank you for your attention. I hope that the broadcast worked okay this time.
Hello.
Hello.
Thank you very much, Paul. Now, before I invite our co-host, Dr. Shende, I will just request Samir to introduce him again through the slide. Our co-host, Dr. Shende, who will introduce to our second keynote speaker. So just before that, Samir, can you play that introduction to Dr. Shende?
Dr. Rajendra Shende is a technology and policy advisor on sustainable development and climate change. He is former director at UNEP on implementation of activities related to the ozone layer and climate protection in more than 146 developing countries. Currently, he is the chairman of TERRE Policy, a non-profit organization that promotes the ideal to think is good but to act is better. He is a graduate of the IIT Bombay. He has received many prestigious awards and recognitions. To mention a few, the UNEP Award, an outstanding contribution to the implementation of Montreal Protocol. He has received a Nobel Peace Prize certificate as a contributor to the IPCC report. He has received the UNEP Partners Ozone Protection Award by Montreal Protocol, a Climate Protection Award from United States EPA 2009, and the list goes on. He has enriched the world community with many of his
Yes, now.
Okay, thank
Yeah,
you.
go ahead.
After listening to that enlightening talk by Dr. Paul Newman from NASA, I'm very delighted to introduce Gilbert Bankobeza. He will be speaking from Nairobi. So having heard Dr. Paul Newman from Washington, DC, now we come to the African continent, Nairobi, where is the headquarters of United Nations Environment Program. And he will be speaking from Nairobi there, from the headquarters. Instead of telling his and describing him, we have a video to introduce him. So may I request Samir to introduce Dr. Gilbert Bankobeza via video? Samir?
Welcome our second keynote speaker, Dr. Gilbert Bankobeza. He is the Chief Legal Affairs and Compliance at Ozone Secretariat, UNEP. Dr. Gilbert Bankobeza is Earth's very own lawyer who has kept international efforts on the path of protecting the ozone layer. Prior to that, he served as a diplomat and a legal advisor in the Ministry of Foreign Affairs, United Republic of Tanzania. Also served as a solicitor in McDonald's and Fruins, barristers, solicitors, and notaries public at Montreal, Canada. Dr. Gilbert Bankobeza published a number of commentaries on international environmental law and a book on the international legal regime of ozone protection. We welcome Dr. Gilbert Bankobeza from UNEP to deliver his World Ozone Day talk and have a dialogue with us.
Okay. Can everyone hear me well? Samir?
Yes, yes, we can.
Yes.
Yes. But now we cannot hear you. Now is.
Thank you. Thank you very much, Samir, for that video introduction of Dr. Gilbert Bankobeza. And with that excellent introduction, I would like to welcome Dr. Bankobeza virtually to India online. So welcome, Gilbert, and floor is yours for a talk. And we are all eager to hear you.
Yeah, thank you for the good introduction. Good afternoon and happy World Ozone Day, everybody. We just heard the role of science and its impact on the ozone layer protection from Dr. Paul Newman. My talk this afternoon will focus on the legal perspectives that have influenced the protection of the ozone layer through the implementation of the Montreal Protocol. I'll be highlighting on a few parameters of success, both past, present, and future. At the expense of perhaps looking at the global scope and its and the impact of the Montreal Protocol globally, Let me mention that perhaps the first success of the Montreal Protocol was the achievement of universal ratification of the Montreal Protocol by the global community. Currently, the Montreal Protocol has been ratified by 198 parties, which includes 197 countries and one regional integration, economic integration organization, which is the European Union. This is not a small measure in terms of achievements of the Montreal Protocol. As we celebrate this day today, we look at an international treaty which has been accepted and is being implemented by the entire world with no recognized state left out. For those who have dealt with international relations and diplomacy, it's not very easy to achieve such remarkable achievement, whereby you have an international treaty whose objectives have been embraced by the entire global community. So I would say that this is one of the critical successes of the Montreal Protocol, which was adopted in 1987 and has since been amended 5 times with the global coverage. Now, how did we get to achieve first the universal ratification? It's because of the objectives which are entrenched within the protocol itself. First, the framers of the Montreal Protocol approached the ozone protection by what legally we call embracing the precautionary principle, whereby at the time of negotiation of the Montreal Protocol from 1985 to 1987, when it was adopted, there was a lot of uncertainty in terms of the impact of ozone depletion to human health and the environment, and another uncertainty bordered on the possibility of phasing out ozone depleting substances in terms of science itself, but also the technology to replace those ozone depleting chemicals. By approaching this protocol precautionary, the first measures agreed by the parties were very modest compared to what we have been doing ever since 1987. Just a simple example, the original protocol listed only 5 controlled group of substances, that is 3 CFCs and 2 halons. But to date, the protocol has listed about 113 chemicals. We have the original 95 ozone depleting substances, and in 2015, the parties added 18 controlled substances which are affecting the climate. So cumulatively, we have more than 100 controlled substances. So you can look at the remarkable progress which parties have been making, led by science and technology, to add more chemicals as science and technology dictates. Another parameter which has made it possible to achieve the phase out of controlled substances under the Montreal Protocol is the trade restrictions which are embedded in the Montreal Protocol. The protocol has a a provision which restricts trade by parties against non-parties in controlled substances under the Montreal Protocol. This trade provision was very critical to enable the majority of states which originally had not embraced the Montreal Protocol and its objectives to join in, because those restrictions encouraged parties to ratify the protocol. Otherwise, they risked not being able to access increasingly limited supplies of ozone-depleted substances. This was one of the elements which parties applied to ensure that every state looked at the positive sides of the protocol and supported the ratification and subsequently the implementation and compliance with the Montreal Protocol. Another parameter which we can look at is being behind the current success of the Montreal Protocol was a stable framework that was built in the protocol itself to allow industry to plan long-term research and innovation to moving away from controlled ozone substances and now lately also global warming chemicals. The protocol provided long-term phase-out schedules and now phase-down schedules of controlled substances, which would enable both the parties, but also science and technology to evolve in order to facilitate the phase-out of these chemicals. If it was abrupt, perhaps, and the phase-out schedule, phase-down schedule was very abrupt and too short, perhaps this could have disrupted the implementation of the protocol and also affected, its implementation. Another parameter which has been instrumental in facilitating the implementation of the protocol is the science, which, as we heard from Dr. Newman, science has been a leader in guiding parties of the dangers or effects of ozone depletion, its effects, and how parties could implement the protocol and avoid those effects which we just heard. We have 3 assessment panels under the protocol, which provides updated science, technology, and environmental effects in order to guide the parties in taking measures where they fall short, in order to be able to stay within the objectives of the protocol. The other element or parameter which has been very useful, especially for developing countries, is a dedicated multilateral fund which provides technical and financial assistance to developing countries to be able to implement and comply with the Montreal Protocol. This fund, which was established in 1990, has to date received more than $4 billion to assist 148 developing countries, the majority of which do not produce the controlled substances. The technical assistance that has been provided has been facilitative in enabling these parties to implement the protocol alongside developed countries. And we believe if it was not for this dedicated funding, perhaps a good number of developing countries would not have been able to achieve or to implement the Montreal Protocol and achieve the successes which we are now witnessing. Another parameter which is built in the Montreal Protocol and has been also helped to ensure that the developing countries and the parties in general continue implementation and compliance with the Montreal Protocol is the non-compliance procedure, which was designed as a non-punitive mechanism to assist parties found to be in non-compliance with their obligations under the Montreal Protocol to return to compliance with the obligations with the assistance of the Implementation Committee and the parties who make decisions based on the information which it receives from the affected parties. If the compliance mechanism built in the protocol was punitive, it would have been easier for those affected parties which from time to time find themselves unable to comply with the Montreal Protocol provisions, maybe to opt out of the protocol. But because ozone depletion knows no boundaries, the non-compliance mechanism was conceived to enable that, rather than punishing those parties, few parties who from time to time fail to comply with the provisions of the protocol, to facilitate their return to compliance as opposed to punishing them. And this has been very helpful in many ways to ensure that whoever party has ratified the protocol, first of all, stays in the fold, that is, stays as a party to the Montreal Protocol, and then he receives assistance to enable that particular party or parties affected to return into compliance. Now, these are a few parameters which I thought that I should mention, which has facilitated the enormous achievements which we have registered under the Montreal Protocol in terms of compliance and phasing out controlled substances. What are the results? Currently, we have a protocol which has about 99% of the listed chemicals, that's controlled substances, especially ozone substances, which have been phased out to date. This is not a small measure. As I said, we started with three groups of three controlled substances way back in 1997. And as the science improved, the more chemicals were identified and listed under the Montreal Protocol. And to date, we have a group of chemicals which numbers more than 100, but out of which 90% of those chemicals have already been phased out. This is not a small achievement, looking at where we started from and where we are. Dr. Paul Newman, in his presentation, mentioned the ozone recovery and the assumptions which we are working within to make sure that we achieve complete recovery of the ozone layer. I won't dwell much on that, particular area, but I can mention the health benefits accruing from the measures which the parties have taken to date. We have about 2 million cases of skin cancer that may be prevented globally each year by the year 2030. This is not a small achievement compared to where we were 32 years ago when the Montreal Protocol was adopted. SATS are also mentioning that if the Montreal Protocol or its implementation progresses at the current pace and consistently, might result in an estimated 1.8 trillion US dollars in global health benefits from 1987 to 2060. Again, this is not a small achievement. We are also told that about 460 billion US dollars in avoided damages to agriculture, fisheries, and materials might be achieved cumulatively from 1987 to 1960, to 2060 rather. These are just hints of what we have been able, we can achieve if there is consistent implementation of the Montreal Protocol from where we started in 1987 and where we are now and where we are heading until we completely achieve the objectives of the Montreal Protocol. In terms of climate benefits, we have been guided by the scientists that an estimated 135 billion tons of carbon dioxide equivalent emissions were averted between 1990 to 2010, contributing substantially to climate change mitigation. What this means is that climate change would have been far worse by mid-century because the chemicals that destroy ozone are also super greenhouse gases and thousands of times more potent than carbon dioxide. Because of this climate element, which is associated with the phase out of ozone depleting substances, we are now told that following the adoption of the Kigali Amendment, whose implementation that is phasing down hydrofluorocarbons, HFCs, will have a big impact on climate change by cutting global warming up to 0.4 degrees Celsius by the end of this century. And this is again cutters of what the Montreal Protocol implementation will be realizing by the end of this century. Now, in summary, you can see that what has been implemented to date by the global community has already registered and resulted into tangible achievements in terms of human health and the environment. However, these achievements, modest or significant as they may appear, should not make the world community relax in terms of continuing to take measures to ensure that the implementation of the Montreal Protocol is achieved completely. We still have some challenges which need to be addressed from now onwards. There are many, but I'll just highlight just three in the interest of time. Dr. Paul Newman dwelt in depth about the role of science. There is a need to ensure robust monitoring, assessment, and analysis of scientific data. If we stop this process, as Dr. Newman has highlighted, we may not be able, in the end, to know what has been achieved, what is left to be achieved, and what perhaps might not be achieved. And therefore, at this juncture, I need to stress the future challenge of ensuring that monitoring of ozone layer depletion, ozone layer recovery, and ozone layer stabilization is very critical to ensure that in the end, we'll be able to assess how far the 198 parties have achieved in terms of protecting human health and restoring the ozone layer. Another future challenge which we are grappled with is about maintaining compliance with the Montreal Protocol, its enforcement, and combating illegal trade beyond 2020. The history of ozone protection has been meeting some challenges over the years, and one of those challenges is the trading of controlled substances under the Montreal Protocol illegally, which happens, I can't say in many countries, but the amount traded illegally, the amount of ozone substances traded illegally is significant, and if it's not controlled, it could undercut the successes and the measures which the parties have been taking to ensure that they fully implement the Montreal Protocol. We need to sustain efforts in that regard by ensuring that there is training, there is enforcement of measures which the parties have taken, for example, licensing systems of trade, customs training, awareness raising, and to make sure that the measures and the regulations which the parties take from time to time are enhanced and enforced fully, so that any loopholes which may lead into illegal trade or relaxing measures which the parties are taking do not interfere with the continuous implementation of the Montreal Protocol by all parties. Another challenge which we currently have is that we have the Kigali Amendment to the Montreal Protocol, which seeks to phase down the production and consumption of 18 HFCs, which have been listed under the Kigali Amendment. At the moment, we have 102 parties which have ratified the Kigali Amendment out of 198 parties to the Montreal Protocol. We still have 96 parties to the Montreal Protocol which have not ratified the Kigali Amendment. And the implication of non-ratification is that, those 96 parties of the Montreal Protocol which have not signed up to the Kigali Amendment can choose to continue doing whatever they want to do with HFCs which are controlled under the protocol. And by doing that, they can undercut and interfere with the smooth implementation and meeting the objectives of the Kigali Amendment. What we need to do, or the international community, it is required to do, is to sustain the efforts in the ratification of the Kigali Amendment to ensure that we achieve universal ratification of the Kigali Amendment as we did with the Montreal Protocol, so that there is no country or party to the Montreal Protocol which does not implement the Kigali Amendment in order to achieve both the climate and the ozone benefits. With these parameters which I have just mentioned and the successes which the protocol has achieved to date, we believe there's still a lot to be done. International cooperation is very important.
Hello.
And we cannot afford to leave the good work which is ongoing unfinished until the full implementation of the protocol is achieved by phasing out all ozone substances and phasing down the controlled substances under the Kigali Amendment to achieve the objectives which are embedded within the protocol. I'll stop here and clarify any issues perhaps which may come up by way of questions or clarifications which may be required. Thank you.
Thank you, Gilbert. Very well said. The challenges that we have overcome and the challenges which lie ahead. What is initially starting from science and then ending on implementation. In between the science and implementation are the countries who did the job, and the people of those countries, the citizens who also participated in it. Of course, the governments were in a forefront, but each of the citizens of the world participated in this. As you said, is 198 countries and nearly 7.5 billion people. So it's a success of not only that of scientists, United Nations Environment Program, but also the civil society. And those are the ones who are going to ask some questions now. And for that, I'm going to hand over to Dr. Gufran Beig. And questions will be to Paul, Dr. Paul Newman, as well as Dr. Gilbert Bankobeza, to scientists and the one who monitors the implementation and the compliance. The great combination. I must thank both of them for enlightening us on this whole process. He is going to ask you, he knows how much time is remaining, so he will take a decision on how many questions can be asked. Probably the remaining can be both Dr. Newman and Dr. Bankobeza can do that by emails because the time is short and Dr. Newman has to leave. But after this question and answer, there is a most important session for which we are requesting Dr. Newman to stay back, is what is called as the best questions that people, that the one who is raising the question, the best questions that can be asked to Dr. Newman, the scientist. And those will follow after the general questions and answers. Dr. Gufran Beig, is from yours.
Thank you, Rajendra. Can you hear me now?
Yes.
Yes. So what I will be doing is that due to the paucity of time, what I have selected, there are a number of questions which has been asked, and especially to Paul. And I just will ask two questions from the audience, and then some 2-3 questions which will be randomly selected from our competitors in the competition, not the prize winners one, because we do not want to disclose the names of the prize winners by asking questions, because they will come to know from the question. So okay, we randomly selected the questions also. So first question to Paul, and that is from the audience. The question is, why ozone hole was not there over tropics?
So can you hear me?
Yes. Yes.
Okay. So when the sun sets over the Arctic in the winter and the Antarctic in the winter, it gets very cold in the stratosphere, extremely cold. Typically, it will be somewhere between -90 and -100 degrees Celsius at 20 kilometers over the Antarctic. Now, the stratosphere is quite dry, but it's not entirely dry. But when it gets that cold, you form little tiny cloud particles. Polar stratospheric clouds is what they're called. They're very beautiful clouds visually. But what they do is they enable a very fast chemistry, a heterogeneous chemistry, in which chlorine can be activated to destroy ozone. So when the sun rises in the springtime over the Antarctic, and that's right now, you get very, very fast depletion of ozone. Now, over the tropics, it's not quite cold enough to form these polar stratospheric clouds. Furthermore, it turns out that tropics is really important to the stratosphere because all the chlorofluorocarbons are getting lifted into the stratosphere, which is at an altitude there of about 16 kilometers. Stratosphere starts at about 16 kilometers in the tropics. So all this air is getting lifted into the stratosphere from the lower atmosphere at 16 kilometers. But it hasn't, the CFCs haven't broken down to release their chlorine at that point. Plus, it doesn't quite get cold enough to reproduce the conditions that we see over the Antarctic and over the Arctic. So we don't get a lot of depletion in the lower stratosphere in the tropics. So that's a good thing that doesn't quite happen. But so it's not quite cold enough, and we haven't actually photolyzed the chlorofluorocarbons to release the chlorine to attack ozone in the lower stratosphere at that point.
Thank you, Paul. I think this covers another question, which was what is ozone hole? So that is perfectly okay. Now there is one more question from the chat box, that why ozone hole is called ozone hole.
Well, why is it called the ozone hole? Well, it's actually a very interesting question. It's not actually an ozone hole. So if you think about, so we have a lot of ozone above us in the atmosphere. As I mentioned, it's on average around the globe, it's about 300 DOPS units, or a layer 3 millimeters thick, not very thick. And not all of it gets depleted. So you don't lose all of it. So there isn't coal there. But when you look at it, you actually see a very low values of ozone over the Antarctic. So back in 1985, when the ozone hole was first discovered, Dr. Beig showed the picture of Joe Farman, who actually discovered the ozone hole. We see this very low values of ozone over the Antarctic, and so it has the appearance of a hole. And so at first, back in 1985, the scientists didn't want to call it an ozone hole. They said, no, there's a little bit of ozone there. It's not an ozone hole. But the term ozone hole was very popular, and so it kind of got established. But it's mainly because of the appearance of it. It looks like there's been a big hole punched into the ozone layer.
Thank you, Paul. Now this particular question is to Dr. Gilbert. And the question is, so it's a very interesting question, that if you were given a power, what single global law you would want to propose to implement to control the ozone layer and climate change? In one single law, if you have been given a power that all the country will follow, what you would like to propose?
That's very interesting. In simple terms, the single law I would propose is the Montreal Protocol substance that deplete ozone layer.
Very good.
Because this is the universal law which has guided the global community to control both the production and consumption of ozone substances. And without this single law, which every state has signed up, we wouldn't have achieved or wouldn't be talking about the achievements which we have registered to date. What happens when this law, single law, is being implemented at the domestic level? It translates into actions, because at the international level, there are global broad objectives, which at the time of implementation, at the domestic level, one has to look at the local circumstances. There are some parties or countries which may choose to go faster, There are some countries which may choose to go slower, depending on the local circumstances, but guided by this single law, which cannot be violated. When you violate it, you face sanctions. I mentioned one example of how, if you are engaging in illegal trade, for example, there are some measures which parties may, take to ensure that, that illegal trade in ozone depleted substances or controlled substances under the Kigali Amendment enforced to make sure that, you don't violate this single law. So the Montreal Protocol substances that repeated the ozone layer is the single law which has been successful to control the production and consumption of ozone substances, and now to protect the climate, which I would recommend to everybody to embrace and implement and enforce. Thank you.
Thank you, Gilbert. Now I am coming to the questions from the competition. As I said that this might be there might be some question which might be get award. Some of the question we may not get award. This is from the randomly selected. The question is to Paul. Is there any particular reason why the ozone layer lies in the stratosphere and not any other place in the atmosphere? Paul, could you hear that?
That's a good question. Yeah. Why is it up in the stratosphere? Well,
why it is available only in the stratosphere, not in any other place? Ozone layer.
Well, there is ozone down in at the surface. That is pollution. As Dr. Beig already discussed, ozone is not a friendly gas. That is, it's great for screening ultraviolet radiation, but it's not good if you breathe it. It's a highly reactive gas. In fact, in the laboratory, you don't want to concentrate ozone because it's explosive. So it's not good to breathe, and it's explosive. I can guarantee you that in the lab, we are very careful about dealing with ozone. Now, the ozone layer is in the high altitude because you need to break
future generations.
Live is on.
That is part of sustainable development goals, which are being promoted by the United Nations, but also is embedded within the Montreal Protocol on substances that deplete the ozone layer. So that is something which I would encourage the younger generation to be careful about, not to pollute the environment. And if they do that, it might become very expensive for them to clean up this environment in the future. Therefore, we have to take every necessary action to make sure that our actions today don't affect the current generation and those who will come after us. Thank you.
Thank you, Gilbert. Now, Paul, would you like to add up shortly?
Well, Gilbert gave a great answer there, so I've got nothing to add there.
Okay. So,
Can I add 2 sentences?
Yes.
Yeah, I just wanted to tell that well, we implemented Montreal without compromising any comfort. In fact, there was a growth and a GDP growth. So nobody is asking you to give away the refrigerator. We are only changing the gas in the refrigerator from CFC to non-CFC. Nobody is asking you to give away car. What we are doing is the car should not use the fossil fuel. So try to find alternative. So the comforts will never be compromised, and our technology will keep on evolving so that we get the comforts all along. That's it. Thank you.
Okay, thank you very much. I think now we should close the question and answer session, and then remaining whatever make the questions will certainly be posted to our guest speakers. And if they get a time, we will certainly, if you can answer, we can give to the people whose questions have not been answered. Now, the last 5 minutes or 7 minutes, we are now, before we go to that last 5-7 minutes for declaration of the results, I request my co-host, who has been, very active here. You can see that participating so enthusiastically, to give his concluding remarks. Dr. Rajendra Shende from Director TERRE Policy Center. Dr. Shende, sir.
Okay, thank you very much, Gufran. And I'm so happy to see Dr. Newman and Dr. Bankobeza, one from the North America and one from Africa. And now we are sitting in Asia. So 3 continents, that is a dialogue which is taking place. And that's why I'm happy about it. The second part is each one, Dr. Newman, Dr. Bankobeza, and Dr. Gufran, all are well-acclaimed scientists and the lawyers in the international field. So I don't think such chance would come again. So I would like to thank them in my concluding remarks, all, including Gufran, for taking this initiative to host this meeting. We are the co-hosts, TERRE Policy Center and IITM. I will not take much time because the time is short and Dr. Newman has to go. So I would only read a couple of sentences and a paragraph from the message which has been sent by United Nations Secretary General Antonio Guterres on the occasion of World Ozone Day. What he says is, and I quote, "As we look ahead to global recovery from social and economic devastation caused by COVID-19 pandemic, we must commit to building stronger and more resilient societies. It is imperative that we put our efforts and investments into tackling climate change and protecting nature and the ecosystems that sustain us." The Secretary General goes ahead and tells that the ozone treaties stand out as inspiring examples that show that where political will prevails, there is little limit to what we can achieve in a common cause. Let us take encouragement from how we have worked together to preserve the ozone layer and apply the same will to healing the planet and forging the brighter and more equitable future for all humanity. And the last thing what he says is, the latest amendment to the Montreal Protocol, which is called as a Kigali Amendment, if implemented, can prevent 0.4 degrees Celsius of global warming. And I would like to remind the audience that Paris Climate Agreement is talking about maximum 2 degrees centigrade rise. And out of that, 0.4 degrees centigrade is already can be taken care by the amendment to the Montreal Protocol. And he, after all, says, at the end, I congratulate the 100 parties that have been leading this example, which are party to this amendment to the Montreal Protocol. And as you know, Dr. Bankobeza told you that still about 98 parties are yet to sign the amendment to the Montreal Protocol. And there are all signs that they will join it. And that's how the Montreal Protocol now becomes a protocol for the climate change, at least the part of it. So that is my conclusion. I again would like to say the uniqueness of this particular webinar and this event, that we heard from the scientists where the problem was identified, and we heard from the one who monitors in United Nations, who made sure that we implement it. And thus was a success. And in between, all of us lie, all the country, civil society. Thank you very much.
Thank you, Shende sir. It was a wonderful summary. And thank you very much for summarizing and bringing the facts that really the world is, we are not very far. We are all virtually close, and we are just like sitting together we feel, and our audience is also feeling the same. Now, coming to a most awaited, another for the young generation and children, as a part of Environmental Information System Resource Partner and then TERRE Policy Center, during this period, every year, there are number of competitions to the school boys, girls, children's, as well as college students being organized physically, but this time we could not do it physically. So we have done it virtually online for last couple of months, invited hundreds of entries in a different competitions have been received, and it was a very tough task for the team, which is comprising of many judges who could find the first, second, and third prize, whatever we could do it. But we were so pleased that we decided that entries all were nice. So all the participants who have participated in this will be getting a participation certificate. And two more things before I go and start playing and announcing the award through again a video link, that the prizes for the winner, they will get it within a 1 or 2 weeks time by courier or by post, depending on whatever the modality we decide. That will be a physical prize. And those who will be getting a certificates or participation certificate within next 2-3 days, they should be getting it either WhatsApp or by email. So that is for the curiosity for all of you. So all of you are going to get it, whoever have participated. Yes.
Gufran, can I just say some couple of things?
Yes, go ahead before something gets
distribution, which I'm sure the whole audience is waiting for the prize distribution, because it was a national competition, and there's many are participants and winners are from the remote corners of the India. Three things I wanted to say. One is, one of the gifts is a booklet on 20 questions and answers on ozone layer, which has been produced jointly by UNEP and World Meteorological Organization, but coordinated by NOAA, that is a National Oceanographic and Atmospheric Administration. And they have sent specifically for the winners, USA, from their headquarters, all booklets to be given to them. That's number one. Number two, I wanted to tell something about Dr. Newman's adventures. And only one adventure I want to say, that he actually goes up to or near to stratosphere with a special spacecraft to measure the ozone levels and even a chlorine radicals. So we heard
in introduction that aircraft.
Oh, right, exactly. So we heard from the scientist who actually measures it. And then I about Dr. Gilbert Bankobeza, that every year he monitors the implementation by calling typical countries one by one and asking them where you stand for the implementation every year. And that continues, and that will continue. So such a strict implementation of Montreal Protocol. These three things I wanted to tell before you start prize distribution. Thank you.
Samir, now you go ahead and quest for the wait has to over. Kindly start playing. All the children are participants who participated should see carefully their name, where it is coming. We will be announcing third, second, and first. First, third, then second, then third. And it will all be displayed in your screen. And the winner is first prize. Paper, get a gift. Congratulations to all winners. And once again, it is a choice of the awards by the judges, but all of you who participate are the winners, equally deserving all the applause, and we will be sending you all the participation certificate. With this, I think I close officially the session. And Shende sir, if you would like to say goodbye to all of them, all our listeners, all our people who patiently listen and enrich their knowledge. Thank you very much to them.
Thank you. Thank you, Gufran. I think the gifts that the prize that the winners will get are amazing prizes. They will further increase the knowledge of the winners. It's not only the booklet of 20 question and answers from USA NOAA, but also the solar lamps, which are assembled by my organization, TERRE Policy Center, and very interesting and selected books that have been bought by Dr. Gufran, Beig, and his team from Amazon. So I think with that, I would like to congratulate all the winners and say that they have done a magnificent job. From Kanyakumari onwards to we have New Delhi and up. So it's a great job that has been done by the winners and the team of Dr. Gufran Beig. Thank you and have a nice time.
So I just wanted to add here that it is not, the prices are not only confined to the books, but I would like to keep it secret also. Sometime from Amazon, you can get it some other surprising price also. Those people. And another very important thing for those who are getting these 20 questions from UNEP, from USA, all of them, I request that kindly get a photograph along with the book with your right hand side and left hand side, because this is kind of a mandatory requirement, and send it to us, because in a NOAA in USA, the organizers of UNEP as well as from NOAA, they would like to highlight that in their achievements from there, that they have inculcated this kind of a booklets in a country like India. So kindly do that, take a photograph, ask your parents or your brothers, sisters to get a photograph along with the booklet. We should be together, and then send to us. Thank you very much. Good night and goodbye.
Good night.